Hi everyone, welcome to our third recap of the video series doing targeting GCE O-level mathematics subject. In this video also, we will discuss two more questions prepared which will cover up some important theories in the syllabus. So let's move into our fifth question of the series. So this will be the fifth question. We kindly request you to take down the question and by pausing the video and try yourself before looking into the workings. So let's move forward with our workings. So in this question, it asks us to find the values of n and m. So first let's find the value of n. Now we know the ACB angle is 50 degrees. It is because AB side is equal to BC side. Therefore, ABC is an isosceles triangle and the opposite angles of these sides will be also equal. Therefore, ACB will be 50 degrees. And then from the triangle ADC, we know that M plus 50 plus 30 plus ACB angle will sum up to 180 because some of the interior angles in a triangle will be equals to 180 degrees. Therefore, M plus 50 plus 30 becomes 80 and ACB is 50 is equal to 180. By subjecting M, you can find the magnitude of M which is equal to 50 degrees. Then from the triangle BCD, we know that n plus 30, it is equal to 180. Once again, sum of the interior angles in a triangle is 180. Therefore, n will be equals to 180 degrees minus 30 minus m. But we have found m is equal to 50. Therefore, 180 minus 30, 150, and m will be 50. Therefore, n will be 150 minus 50, which is equals to 100 degrees. In this question, in the given square ABCD, M is the midpoint of the side AD and E is a point on the side AB. When extended, EM and CD meets at the point F. Copy the diagram to your worksheet and prove that this triangle AME is congruent to the triangle DMF. Now we know from the given two triangles AM is equal to MD because it is given. And also we know that AME angle, this angle will be equal to DMF angle because these are opposite angles. So the opposite angles are always equal. Also we know that EAD angle, it is equal to 90 degrees, is also equal to FDM angle because 90 degrees. Here EAD angle is equal to 90 because it's a corner of a square equal to 90. And FDM angle is 90 because CF is the straight line and we know CDA is 90 degrees because it's a corner of a square and sum of the angles in a straight line is 180. Therefore, FDM will be 180 minus 90 is equal to 90. Therefore, this angle is 90 and this angle is 90. So from these reasons, we can say that triangle AME is congruent to triangle DMF because angle, angle, side, angle, angle, side concept. Then it asks show that AEDF is a paragraph. So let's join AEDF. So this will be my AEDF. So in the quadrilateral AEDF, now we do not know whether it's a paragraph or not, so it is better to mention it as quadrilateral in your first instance. We know that AE is equal to DF because we prove that AME and DMF are congruent triangles. Therefore, the adjacent sides of congruent triangles are equal. Therefore, AE equals DF. And also we know that AE is parallel to DF. Now AE is a part of the side of the square AB, right? So AB is a part of a square and side of a square and AE is a part of it and CD is the side of a square and DF is the extended version of it. Therefore, we know that CF is parallel to BA, thereby EA is parallel to DF. So since two sides of a quadrilateral are equal and parallel, it will become automatically a parallelogram. Therefore, AEDF is a parallelogram. Now, in this question, it asks the line perpendicular to AD through M intersects DE and G at B, intersects DE at G and BC at H. So let's draw the data into a diagram, and we need to show that BG is equal to GE. So this is my perpendicular, and it meets DE at G and BC at H. Now from the triangle ADE, this is my ADE triangle, we know that MAE angle, that is MAE, this angle is 90 degrees. It is because ABCD is a square. So corner of a square is 90 degrees. And also we know that this DMH angle is 90 degrees since it's a perpendicular. Thereby, AE will be parallel to MG because these angles are corresponding angles. Therefore, this AE side and MG will be parallel because of the corresponding angles. And by the inverse of the midpoint theorem, we can state that BG is equal to GE. Now, in the midpoint theorem, it says when you draw a line from a midpoint of a side of a triangle to the midpoint of the opposite side of the triangle, the line become parallel to the third side of the triangle. In the inverse, it says when you draw a line from midpoint of a side of a triangle to its opposite side and is parallel to the third side, and if it is parallel to the third side of the triangle, that line will bisect the opposite side. Therefore, using that inverse theorem, these two lines are parallel, and this is the M is the midpoint. Therefore, that line will bisect DE, and therefore G is the midpoint of DE. Thereby, GE is equal to DG. Now, in this, it asks us to area of the DGM, the ratio of area of the DGM and area of the parallelogram AEDF is equal to 1/8. Now, we know the area of DGM, that means this triangle DGM is equal to EGM, that means this triangle is equal to half DEM. Half DEM. Let's see what it is. Now this is the perpendicular of this triangle. Now if you want to find the area of DGM, that is DGM, this one, it is half into GD into this perpendicular height. And if the area of EGM, it will be half GE into again the same perpendicular height because it has a common vertex. Therefore, the same perpendicular height. And we know the base lengths are equal since we have proved it earlier. DG is equal to GE. Therefore, base lengths are equal, perpendicular heights are equal. Therefore, the area of EGM will be equal to the area of DGM, and thereby the area of DGM will be half of this whole triangle, that is half of DEM triangle. And again, we know that AME, because of the same reason, we can state that AME triangle will be, the area of AME triangle will be equal to the area of DEM. DEM is this. You know, the base length is MD and here base length is AM. Those two are equal. And the perpendicular height is AE. It has a common vertex. Perpendicular height is AE. Therefore, base lengths are equal, the perpendicular heights are equal, thereby the areas will be equal. And therefore, we can state that AME triangle, the area of AME triangle equals to area of DEM triangle. It can be written as half of this AED triangle. Half of AED triangle. But we know that AED triangle is equals to the half the area of AEDF because AED is the triangle in between the parallel lines of the parallelogram AEDF. So the area of that triangle will become half of the area of the parallelogram. So that's a rule. Area of a parallelogram is twice the area of a triangle between those parallel lines. So now we know area of DGM is equal to half the area of DEM. You can replace this DEM by half the area of AED. Again, you can replace this area of AED using half the area of AEDF. Therefore, area of DGM will be equals to half into half into half the area of AEDF. Once you multiply, it will become 1 over 8 area of AEDF. So once you cross multiply, area of DGM divided by the area of the parallelogram AEDF will be equals to 1 over 8. Therefore, the ratio can be proved like that. Now, this will be the sixth question. So again, you can pause the video and write down the question and try yourself before looking into the workings. Now, in this, the diameter of a circle with the center O is 20 centimeters and the length of the chord AB is 12 centimeters. So we need to find the length of OX. Now we know the diameter is 20 centimeter, thereby the radius become half of it, which is 20 over 2 is equal to 10 centimeters. Also, since O is the center, OA and OB will be radius. Therefore, OA is equal to OB is equal to 10 centimeters. And AB is given as 12 centimeters. AX, since OX is the perpendicular, right? Since OX is the perpendicular, X will bisect the chord AB, right? So AX will be equal to XB equal to 6 centimeters because the perpendicular drawn to the chord from a chord of a circle from its center will bisect the chord. So this is the center and this will be the perpendicular drawn. So X will bisect the chord AB. Therefore, AX will be equals to XB, which is equal to 6 centimeters. Now, by applying the Pythagoras theorem to the triangle AOX, we know this is a right angle triangle, so you can apply Pythagoras theorem. We know the value of radius. We know the value of AX, so you can find OX. We know AX squared plus OX squared is equal to AO squared. Therefore, OX squared is equal to AO squared minus AX squared. AO squared is the radius squared, which is 100. And AX squared is equal to 6 squared, which is 36. So OX squared will be 64 square centimeter. By taking the square root, you can find OX, which is equal to 8 centimeters. Now, in this part, in the given diagram, angle BAP is equal to CAP. So here it is BAP, which is this angle, is equal to CAP, which is CAP, this angle. The tangent drawn to a circle at B intersects the extended AP at Q, this one, and given that BQ is equal to QC. Now, it says if angle QBP is A, express the magnitude of BAC. That means this whole angle using A. Now, let's mark it as A. Now, we know QBP is A. QBP is A. It is given. And QBP is equal to BAP. QBP is equal to BAP. We can straight away write like that. The reason is that the angles which are tangent to a circle makes with the chord drawn from a point of contact are respectively equal to the angles in the alternate segments of the circle. So this will be my tangent. This is my chord. So the angle in between will be equals to the angles made by the chord in the alternate segment. So this is the segment. So this small segment will be the segment which includes our angle, right? But we need to consider the opposite segment. Therefore, the angles the angle which a tangent to a circle makes with the chord, that means A, drawn from a point of contact are respectively equals to the angles in the alternate segments of the circle. This will be my alternate segment. This is the segment, the small part will be the segment which includes my angle, and this will be the alternate segment of that angle. Therefore, the angle made by the chord in the alternate segment will be equals to that angle A. Therefore, we can straight away write QBP is A. It is also equal to BAP. So BAP will be A. Now we know BAP is equal to PAC. It is given that BAP is equal to PAC. So it is the data given. Therefore, this will be A and this will automatically becomes A. Therefore, our task is to find the BAC. So BAC will be the summation of those two angles. Thereby, BAC will be equal to BAP angle plus PAC angle, which is A plus A equals to 2A. Now we need to answer, show that angle BCQ is equal to BAQ. Now, BCQ is equal to BAQ here. So this angle is A. We have shown that this angle is A. Now, BCQ angle is also A. Now we know that BQC triangle is isosceles because BQ is equal to QC. Therefore, these opposite angles will become equal. Therefore, this is A. Therefore, the BCQ angle also becomes A. So we can show that angle BAQ is equal to angle QBP equals to A. We have proved it earlier. And also we know that angle QBP is equal to BCQ because BQC triangle is an isosceles triangle since BQ equals to QC. So thereby we can show that BAQ is equal to QBP is equals to A. Now we need to prove that ABQ is a cyclic quadrilateral. Now what is my ABQC? ABQC. So in order to show that some kind of a quadrilateral is cyclic or not, you need to show that the opposite angles sum up to 180. So the summation of this angle plus this angle should be 180 plus the summation of this angle and this angle should be 180. So let's see how we do it. We know that BQC, that means this angle, is plus BCQ. Now from the triangle BQC, we know this triangle is isosceles and we have proved that this is A and this is A. Therefore, this angle will become 180 minus the summation of these two because sum of the angles in a triangle is 180. Therefore, BQC, that is the angle which is included in the cyclic quadrilateral BQC, is equal to 180 minus A minus A. So it will be 180 minus 2A. So 180 minus 2A. Now BAC is 2A. Now we have proved that BAC is 2A because BAP and PAC is A. Therefore A plus A will be 2A. Therefore BAC angle is 2A. Thereby BQC, which is equals to 180 minus 2A, and this is 2A. Therefore, the summation of these opposite angles will be equals to 180 minus 2A plus 2A is equal to 180. So now we have shown that two opposite angles are sum up to 180. Now we need to check for the other two opposite angles. Now we know angle QBA, this is QBA, is QBA plus QCA plus QCA. That means this angle plus this angle plus this angle. Now since it's a quadrilateral, ABQC is a quadrilateral, Therefore, the summation of the interior angles will sum up to 360. We know that from the theorem, right? So now we know the summation of these two angles will sum up to 180. Therefore, the summation of the remaining two angles will be equals to 360 minus the summation of these two angles. Again, we can show you that QBA plus QCA plus BQC plus BAC is equal to 360. We know that QBA plus QCA is equal to 360 minus the summation of these two. These two will be sum up to 180. We have proved it earlier. So 360, you put it to the other side, it will be going as a minus. 360 minus 180 becomes 180. Therefore, automatically, the summation of these two opposite angles will also become 180. Therefore, the opposite angles of ABQC sum up to 180. Thereby, ABQC is a cyclic quadrilateral. Now we need to show that the triangle BPD is an isosceles triangle. So, which is our triangle BPD? So, BPD, we need to connect it. So, let's connect. So, this is our BPD. Now, we know that PBD, this angle is equals to PAD. This is PAD, right? PAD. Now, you know this PD is a chord. PD is our chord, and the angle subtended by the same chord, on the circumference of a circle will be equal in magnitude. Therefore, PD is my chord, and this is an angle subtended on the circumference by that chord, and this will be a angle subtended on the circumference of the circle by the same chord. Therefore, this angle will become equal to this angle. Therefore, PBD, which is PBD, is equals to PAD. So, PAD, now we have proved it earlier, is equals to A. We have proved it earlier. PAD is equals to A. So, thereby PBD, which is PBD, this angle will also becomes A. Again, PBD is equal to A. Now, PDB, which is this angle, PDB, this angle will be equals to PAB, which is PAB here. Now, if you take the BP chord, now this BAP angle will be angle subtended on the circumference of the circle by the chord BP. And again, this BDP angle, this angle will be an angle subtended by the chord BP on the circumference, same chord. Therefore, these two angles are also equal. But we have proved earlier, BAP is A. BAP angle is A. Thereby, PDB angle also becomes A. So PDB angles become A. So this angle will become A. Now this is also becoming A. Therefore, these two angles are equal. Thereby, these two sides BP and PD will become equal. Therefore, BPD is an isosceles triangle. If two angles in a triangle are equal, it is an isosceles triangle. All right. So with that, we will wrap up the session and hope to see you all with our fourth recap with some more important theories. Until then, stay safe and goodbye.